This is the ecosystem of enterprise DNS. Lots of moving parts in here, and we have about an hour. I probably will take up about another 40 minutes of that, and then we'll whatever. But this is where we're going to hang for the rest of the time here. What's the matter? What did I do? What was funny? That's awesome.
Just you.
I'm a quirky dude. What do you want? All right, so this is the ecosystem of enterprise DNS. And so with that, there's lots of moving parts, and we're going to break this down and eat this elephant a bite at a time. But if we think about what we're doing in our organizations, if we think about this as on-prem, and we think about that as cloud, and we think about that as external-facing services or the external-facing name services that we need to provide, and then we think about what we're doing in SD-WAN and SDN, and then off into managing or providing namespace for SaaS, for cloud-based environments or integrating with them, this is the entire ecosystem of enterprise DNS. Because it resolves everything that we need to resolve, all authoritative and IP connectivity and resolution for our on-prem and into those environments connecting to. So automation, cloud, visibility and control, and an element of security, right? Our defense in depth strategy. And so we'll begin to break down what that means. Any questions? Has something struck or been thought about that I haven't brought up so far? Because we're going to hang here for the rest of our time.
You did, but we will talk about it, use case of enterprise DNS and BlueCat for the SD-WAN, right?
We will, absolutely. Yeah, it's a big one for us. It's an absolute big one. And what we're finding is that cloud right now is the hottest topic, right? At least for the engagements that we're in. And very closely behind it is automation. And then SD-WAN is definitely becoming more and more and more hot. And so if you'd like for me to touch on that one first, I'd be happy to. Should we use that one as the first use case?
I just can wait.
Go right ahead.
Yeah. So before you get into this, I want to talk a little bit about, we've talked a couple times today about our engagement. I know you had a question on Twitter about kind of our automation and how we do that from an API perspective for our customers. And one of the things I think is really clear is a long time ago, I worked at Symantec, and at the time, I was an SE, and I was taught that I should go in, and one of the questions I should ask my customers is, what percentage of your environment is virtualized? And most of the time at that period, I think it was 2011, I would get 15, 20%. Every once in a while, I'd get a guy who'd just gotten budget, and he'd be, oh, we're 85%, everything's great. And a lot of times when we talk to, and you mentioned kind of the small, medium business earlier, we talk to some of those customers, and I hear this on the Packet Pushers podcasts when I listen to them, not everybody is ready to start coding in Python yet, and not everyone is ready to start designing their own workflows. And so when we engage with our customers, one of the things that's critical to us is we sit down with them, and we're not just charting out their path to enterprise DNS, we're charting out how can we help them with the automation of workflows. One of the ways that we do that is by providing them a portal as part of the product that can allow them to do either self-service or machine-to-machine communication, and sitting with them and really understanding what their use cases are. We have a whole bunch of sample workflows that we provide to customers so that they can kind of get started and tailor those to what they need. And we also offer them kind of consulting support, not just to do it for them and then we're constantly embedded and they're having to pay and all of that, but to really teach their staff how to actually take advantage of this in a meaningful way. And so I wanted to just kind of touch on that before. That's definitely part of our overall engagement. So
absolutely. Questions or comments on that? Okay.
Question for you.
Sure.
You asked what's missing in the slide.
Yep.
I've been drinking a lot of container Kool-Aid lately.
Okay.
So I'm thinking service mesh and
Sure.
services.
What's on your mind around, what's troubling you about containers related to our discussion today?
Not particularly. It's another instance of anything that's external facing, I would assume, is relatively static as compared to spinning up.
100%, right? And so, look, I have global external DNS up there for this reason, and that is that it's important to our customers, right? And so it is a part of, it's probably the smallest portion of enterprise DNS that we focus on until our customers come in and say, well, I don't want to host my DNS anymore, or I do want to host my DNS, but I want to do it more effectively, or what are the options for still managing the external DNS, external facing critical DNS that we have for our retail portion of our business or getting to us in general without having to host our own infrastructure, yet still being able to manage it and rolling it into the fold of the unified enterprise DNS story and automating against that, right? So I leave it up there for that very reason, and it becomes actually the most straightforward portion of DNS that we have, right? But it's still extremely important. I mean, think about, if I can't give any names and I won't, but I haven't even been tempted to today. I thought I was going to. But if you think about the organizations that we have, they have a huge internet presence, and a lot of their revenue is based off of that internet presence, which means if their external facing DNS is down, they are instantaneously losing millions of dollars, right? So it's a huge, huge, huge topic, although it still becomes one of the more straightforward topics that we have related to DNS, and that's why I absolutely leave it up there. I do like the container story, and we've heard that in more and more, hey, what are we going to do for the IP space related to these containers? Or moreover, how are you going to help us spin up these containers faster and faster? And I think it really doesn't specifically relate to containers themselves as it does to fall into the workflow and the business logic that we create and then allow you to consume in whatever mechanism you're going to use to spin up or self-service or whatever the IP space that we hold for whatever containers or any other computes that you're trying to stand up on the network.
You're going to spin up the containers, and they may be offering a service to your users or to the external world, but that is going to be a fairly static interface.
It
in
is.
terms of naming and
From a naming standpoint, once that container is up, that container generally doesn't move, right? It might move, and if it does move, the mechanism for making it move needs to interact with our own naming system itself, and back into the workflow system it goes.
Well, this is more like the service mesh or the scheduling system will have an external-facing service address that then translates into what the containers may be very, very short-lived, but that's under the hood.
That's right. And so I do like the phrase here because it short-lived, right? So whether you're talking about cloud, whether you're talking about containers, or you're talking about instances in the cloud or services in the cloud, they may live for only a few seconds. They may be stood up, they may be consumed, and they may be stood back down. They may be taken back down. But the DNS needs to keep up with that. And quite frankly, so does the IP space. And so being the single source of truth of that is critical, because I don't want to go in, just like, in the slow-moving world of VoIP, right? Where we had clients and servers and phones. I mean, it was pretty easy. Those requests came in, they trickled in. But now requests are coming in lightning, and they're lightning fast, and they're coming in hundreds, if not thousands at a time, right? Have to be allocated. They need to be available for consumption on the network. So allocation is one thing. Being ready and consumable on the network is another. And quite frankly, deallocation of the name and the IP space is just as important as standing it up, right? Because we're trying to maintain our ultimate goal here is to be the single source of accurate truth, right? I guess those are redundant words, but single source of truth, right? Not the single source of some muddy waters, right? That's where we are today. That's what we're trying to clean up in the future.
That makes me wonder. You're talking about rapid changes. How does BlueCat maintain the synchronization of state between obviously you're going to run more than one instance for redundancy. And if we're talking about rapid fire changes,
Yep.
How do you guys maintain that between?
There's a couple of ways. That's a great question. And so obviously we have to have redundant sources of data, and we do so. The second portion is not just the data elements itself, but what happens if a remote location is offline from where that data store is, right? So geographically, we're going to separate those data sources. And then here's where we're beginning to change, and it gets into some things that we were talking about earlier, Ethan, where we were talking about how are we going to make our calls? Are we going to make I'll give you the breakdown, lay of the land really quickly before I get into that. Lay of the land really quickly. That's the only name we have on there. I apologize for having that on there, but the address manager is our data source, right? I should have taken it off, but I forgot. So, but this is our single source of truth, our management head, our management platform for everything BlueCat as it relates to the data set of the DNS data, so the namespace, the IP space, devices that are on the network. This is where we do our configuration. This is where we do our deployments from, et cetera, et cetera. This becomes our single data source management head, and we make it redundant, right? The other pieces you have here are in a traditional, doesn't really matter what the architecture here is. You've got authoritative DNS, you've got IP distribution, you've got cloud DNS, And then something that is very interesting for us, again, I guess I have another product name up there, which I didn't, but this is our automation platform. And what you'll notice is that while the traditional call might come back here, this is where the traditional API lived. It used to be SOAP, right? I guess you could still make a SOAP call if you wanted. And then REST there too. That's the traditional way, whereas I'm gonna create some fun stuff in programming or scripting somewhere else, and I'm gonna call in individual API calls back here. That's the old way to do it. The new way to do it, which we're talking about workflows, is where we build our workflows into our automation platform. The interesting thing is, and the use case around either cloud or off-prem or on-prem or whatever it may be, is that we can take these and put them anywhere we want, right? And so if I know I'm gonna be doing a great deal of automation from any one given area or another, we will put our automation platform locally to that particular area. It's a service point at the end of the day. It's also a container, so we can put that wherever we want. And then it becomes where we call into the workflow. So whatever we're trying to accomplish, we call into the RESTful endpoint that's sitting out there on the workflow here. We'll do all the business logic here. One of the things that we can do is understand the connectivity state to where the single source of data truth is here. And if we need to, at that point, interact with the local service mechanism of DNS itself, we can certainly inject those records there, right? And save the information for the database when it comes back online. If we need to save that, if it's an IP request or something like that, we have ways that we can cache that information, and then when it comes back online, send it back out or make the request, right? So we will put these areas, or put our workflows or our automation mechanisms out in each of the different areas where we plan to do automation, right? And so again, the source of the redundant source of data is a given. Been doing that for a long, long time, but now in the area of automation, it is critical for not only the single source of data itself to be redundant, but anything calling back into our single source of truth or asking questions of be redundant in those specific areas.
And you're continually validating against the network in your DevOps CI.
You know what? It depends on the workflow. And so when we get into cloud,
wouldn't that be necessary though to maintain that level of accuracy though?
It does. So it depends on how you write the workflow.
Yeah.
So we have a caching workflow, for example, that does nothing but check the state. And I don't care what the request is that you're calling. It's going to flow. It's going to flow through my caching workflow. I'm going to check back. Can I reach my single source of truth, or can I not? Or whatever other mechanism I might be touching. So the communication is not only between here and here, but what we might be communicating back with the other applications that we're trying to integrate with.
No, I mean specifically the data set that you have living on the address manager.
True that. Yeah, I get it.
So single source of truth ultimately is the network and all the various devices. So it's kind of like a proxy single source. I mean, which I completely agree with what you're saying, but just to get it really.
I get it. So
about it.
what I'm saying though is that if we're coming through here, we have caching workflows that will check the state. And so I don't really care what the request is. If I need to come through the caching workflow, I'll just come through the caching workflow. So it's one that we've created to say any workflow that needs to be aware of network changes or state itself and be cached, we can. If it's a workflow that was always destined for the local service point, then we may not need to. For example, if we do something specifically, and I know it's AWS specific, if we do something specific inside of a VPC itself, I don't really care about anything around the network because I'm autonomous in that VPC, right? But if I'm doing something against the shared services area, or more specifically, if it's destined for the on-prem area, then I need to cache it, because then I do need to be aware of that network state.
So it's more efficient that way, it sounds too.
It's more efficient, and then we can make some intelligent decisions there too. Is it faster for me to go interact with a data set, or is it faster for me to get this done because maybe it's going to be super short-lived, right? And I only need it for a few minutes, that I might not need to hit my data set. I might need to put it in and take it out just as fast. It's faster to do that than to phone home, to get all the way home, create it, live with it, then deallocate it later, right? So, again, this is one of those things where if we do that against our automation platform, we would never be able to achieve that against an API. Right? It's too complicated, and we recreate or boil the ocean time and time and time again, right? But doing it here, creating that business logic there, gives us a lot more flexibility in speed, redundancy, and then what we can actually accomplish. This also gives us flexibility against the different things that our customers want, right? So I'll give you a cloud-specific environment, or cloud-specific, or a conversation, not even cloud-specific, but a conversation I've had recently with, they happen to be headquartered out of Fort Worth, very large insurance company around the world. That in their cloud, they don't want any duplicate names, even though they may have duplicate spaces in VPCs. They don't want any duplicate names, and so while DNS supports that, DNS is okay with that. It might not be best practices, but you can do that in DNS. But specifically for their business, they don't want to do that. And so with that, we can write that logic straight into the dynamic calls around DNS registration that is in our automation platform. And so they can take that generic dynamic updating workflow and customize it for themselves and say, we're going to add in the business logic or add in the module, if you will, inside of that workflow that says, don't allow duplicates. And that's one of those things that we can give back to the community as well by way of doing it through the workflows. Now we can add that module to that particular workflow and give it back to the community, and they can consume it. If we were using the traditional call against our API model, every single API would be specific to every single environment, and we wouldn't be able to give that logic back. That's a lot of talking. Did I answer your question?
Are you, me or him?
Both of you.
Both of us?
Yeah.
Yeah, I mean, yeah.
Oh, it's a very questionable.
You didn't like that one?
No.
Yeah. Let me think about how to rephrase my follow-up, or
Okay.
rephrase in the first place my follow-up.
Fair enough.
Okay.
Yeah, absolutely.
Maybe get some more coffee too.
Sure. Look, here's the interesting thing about the cloud conversations that we're having. It's very easy to go spin up a cloud instance, whether it's Azure or Google or AWS, and go play around. It's a whole nother ball of wax when you're trying to extend and get client connectivity back into the cloud. And so what's not represented here is what's on this slide, and that's where the client community lives, right? And so while this is where BlueCat fits, and this is the ecosystem of enterprise DNS, the clients usually fit right down in here somewhere. So if this is our on-prem data centers and remote locations, our clients are living and breathing and working and accessing the networks down here. Today, that's the model. Tomorrow, we're going to be all over the place with connectivity, and so we have no idea where the difference between a corporate network and the cloud network and private whatnot. But it is important. The most important part about this entire conversation is understanding that that client living down here, wherever that is, needs resolution to all of the resources that we have available to them for the networks that we are allowing them access to, right? And so it's no fun to provide them all of these really cool environments in cloud and on-prem and remote and whatever if we can't get them to those resources. They're going to go swipe their credit card and go get their cloud wherever they want it, shadow IT, whatever you want to call it, right? And they're going to go get what they need. And they're going to fall outside of the best practices and security policies and mechanisms that you've put into place to protect the network and protect yourself against them on your networks. And so with that, specifically in the cloud, presents some super interesting challenges, again, because all of the different cloud vendors provide their own DNS, right? And so just extending ourselves into each of those cloud environments is not enough, right? And so there's 3 use cases here, or there's 2 use cases specifically. That is, what am I going to do about EC2s? For example, I'll stay specific to AWS, just because that's what it's up here. But what am I going to do about specific computes, or in this case, EC2s inside the VPCs on any given AWS cloud, right? Those behave, or those are treated, or they should be treated, they could be treated as any other compute that we stand up anywhere in the environment. And that's actually the most straightforward one that there is. And so with that, there's some nice built-in monitoring and execution tools into the clouds that allow us to handle or interact with that IP distribution system that any given cloud is always going to hang on to, right? And so if we go back to the visibility and control, number one key value driver, in my opinion, of organizing these core services and management together into enterprise DNS, we are missing a key element in the cloud, and that is that we don't own IP distribution. We own IP distribution on our own networks, and we own it from a static standpoint and from a dynamic standpoint. But from the standpoint of the cloud, if we want to go set static, we own it, but most of the time they're not static. 99% of the time they're not static, and we don't own the distribution of the IP space. So we have to figure out a way to exchange information or get notified or the word I was looking for is interact with that IP distribution mechanism in the cloud. And we do so through the built-in tools of those, through monitoring and execution. Find, create, start, stop, terminate on any given EC2. We can understand that. We can interact with our automation platform, write workflows around that, create business logic to say no duplicates, for example. It gets injected either directly into DNS or back into our source of truth and distributed out. That's a fairly straightforward one, although at first it seemed quite complicated until we brought on things like advanced services and platform services, whereby we absolutely have to rely on the built-in DNS that the cloud vendors provide. And so herein lies the challenge. While the first one was complicated at first, we solved it, right? We figured out a way to interact with that IP distribution. The second one, we haven't solved, now we're having to play nicely with. And this is where naturally, when we come back into intelligent DNS, this is where this really plays in, because we have some decisions to make, right? Where am I going to go? What advanced services am I using? What platform services am I using? Am I using them in a shared services environment, or am I using them in a specific area of any given cloud? What account am I using them on? Am I doing peering? Am I doing this? Am I doing that, right? And so with all of that, there is no way. We could, actually I take that back. We could create forwarding rules and forwarding rules and forwarding rules, and we would just add to the problem that we're trying to solve, which is, let's do some intelligent routing. Let's not just create rules everywhere, static rules that we have to manage over and over and over that we forget about or that will break, things of that nature, right? So with that, when we put in our capability of intelligent routing into the cloud, right? Not only have we solved the bidirectional resolution and visibility of the computes or the EC2s that are standing up in AWS, for example, now we have been able to intelligently find out, again, I need advanced services that has this specific host name, and I'm asking this VPC-based DNS because that's where it lives. So if you know anything, and by the way, who's working with cloud? Ooh. So a hot topic for us, maybe not so hot topic for you guys, but what ends up happening is those advanced services need to get consumed from everywhere, and they might live specifically in one of the different areas, and DNS lives specifically in the cloud in that area. We have to get to it, but I don't know which one. And when we have customers telling us that they're using hundreds of VPCs and those advanced services in most of them, and I need to consume them, and they're using the same namespace around them, I've got to start asking you, and you, and you. But if you give me an NX domain in a traditional DNS fashion, I'm done. So we use intelligent routing to get there. That's one of the ways that we solve the platform services and advanced services that our customers are using in the cloud as we're extending our DNS out into the cloud. Yes, sir.
So intelligent gateway is doing this automation, right?
I'm sorry?
Intelligent gateway is doing, integrity gateway, sorry.
Intelligent, I'll just call it intelligent DNS. We're calling it intelligent DNS.
And you have
Oh, gateway.
integrity gateway, and it's doing the automation part, even in the cloud. So my question is it doing whatever it is doing for IPv4? We are also doing for IPv6 as well, right?
Sure. So if you think about this, though, so I get the IPv4 versus IPv6. At the end of the day, it's data, right? And I get it. It's IPv4 data, it's IPv6 data, but sure, the same problems are present, ever present, whether it is v4 and v6. V6 provides some more challenges. It depends on, actually, I take that back. It depends on what challenges you're facing, right? Overlapping IP space, IPv4 problem, right? And now we really get into some namespace problems when we start dealing with NATs, right? Because I can't just route there. I might have to actually figure out where it is by name, right? So that's one of the ways that we can solve that problem. But you're right. So I hate using product names here, but Integrity Gateway is our automation, and we have a different capability for the intelligent routing is at the DNS. It's one of our DNS service points. That answer?
Yeah.
Okay. Any other questions around cloud? What we're finding, again, for the projects that my team or the engagements that my team is on, cloud is the number one thing that we're working on today, right? You want to get into the SD-WAN and the automation? Automation we've talked about. Let's get into SD-WAN. Specifically, I assume you're working on SD-WAN projects today? Yeah. Also, like what sorts of things are you doing around SD-WAN today?
Actually, I am wondering, your product, what's the use case for the SD-WAN? What's the capability? So what's the benefit if I use BlueCat here for any SD-WAN solution?
Sure.
vendor regardless. So
Here's what you'll find is, again, our challenge, our goal is to become the end-all, be-all, single source of truth of the IP space. And we house certain pieces of data that are pertinent to being that. And when you talk about software-defined network, if you talk about networking in general, forget software, right? If you talk about networking in general, if I need to stand up a new VLAN in my data center, or if I need to stand up a new office, actually, I'll get to that in a minute. If I need to stand up, in a traditional way, if I need to stand up a new office, if I need VLANs, I need subnets. If I need subnets, I need to know where they are. In contiguous routing, that's great. I might have a block structure. In non-contiguous routing, I might be all over the place, right? And so the idea here is that you need IP information for your new network, whether it is software-defined or not, right? And so we house that. We also are extremely flexible in what data we can house. And so the biggest challenge that you'll find when you have a single source of IP space is if I'm non-contiguous. In fact, I'm not a networking guy at all, right? The guys that are actually requesting the information are typically not networking guys. They know nothing about IP space. They know everything about the fact that I'm in Dallas, Texas, that I'm in our corporate building number 4, that I'm on the 3rd floor of that building, and I'm in closet whatever, right? That's what they know, right? And I'm trying to find some IP space. And so the toughest challenge, or the biggest challenge that you'll find is how do you relate that data, the IP data itself, the routed data, back with the business logic that we have that we relate the two together. And so automation, whether it's software defined or it's a business process or single service or into SD-WAN, is how can I appropriately and effectively get to the IP data that I'm looking for in the right area based off of this business logic, right? And so we have the flexibility to add those data elements into and on top of the data elements that we have. How you come and consume us is irrelevant, right? And so that's why I'll always go back to how do you integrate with this and that? Workflows. How do you integrate with this and that? Workflows. Whether it's self-service, SD network, software-defined networking, SD-WAN, we are working specifically with some technologies that I won't mention necessarily unless I have to, but that are, so we're trying to get very specific in what we will actually prove and show and do ourselves, but moreover, we're building workflows so that our customers can come consume us however they want. There is a company in, as far as the detail that I will give you, they're in Graz, Austria. They do service, or they do network connectivity and compute availability for customers of theirs to come back and do software testing, right? For example, I doubt you'll be able to figure that out, so that's good. But anyway, they provide this cloud space, private cloud space and compute availability so that these customers can come in, consume those services, install their software, test their software, and get out. They have completely against an ACI infrastructure, right, where they have compute stretched across all kinds of things. They've got VMs, they've got cloud, they've got their own cloud, they've got virtuals, whatever, and it might not be in the same area, and they're using the ACI fabric to actually get back and automate against the data that we're using here. And if you go in and take a look at what they've done is, it's not about a block and a subnet or an IP address and a DNS record, although at the end of the day, that's the end goal, is to set the DNS record for the IP address, right? So that we can get resolution to it. But to get there, all kinds of data elements have to have been traversed, set and traversed. And so that's really, if I talk about SD-WAN and not be specific against any one given vendor, because quite frankly, it really doesn't matter, right? When you're looking at those data elements. And so our biggest challenge here is to work with the organizations to say, let us help you set up the data elements here that you will need. And we can do that in an automated fashion, quite frankly, right? Set the data elements here that represent the business logic that you need to get to related back to the blocks and subnets and IP addresses and the namespace, so that then we can build the appropriate workflows so that your SD-WAN vendors and applications can consume that appropriately and give us what we want. Stand up a tenant, stand up a compute, stand up a web service, stand up whatever you want, right? As long as we've related that data back appropriately and created the right workflow and set up the RESTful endpoint, it doesn't matter what applications come in to consume us.
Thank you. The concrete example helps their business logic as a little nebulous for me, whereas I have a tenant, they're in a VRF, and I need to map those to the addresses that I intend to assign to that particular customer.
So if you think about what a tenant is, right? A tenant has. Well, I'll just go back to AWS since it's up here. If you think about what a VPC is, great. I can go into the AWS console, and I can say stand up a VPC. But instantaneously, so all the automation around standing up the fabric behind that is done in AWS. But I still have to give it routes. Still have to give it subnets. I still have to determine how many subnets and how many routes do I want in any given VPC. And when that happens, I've got to come back to Blucat, right? As I start standing up services or standing up EC2s in that given VPC, I've got to get back to Blucat because I've got to get the IP. I'll take that back. In this model, in the VPC model, once I've got the route and subnet, it's going to distribute the IP address, but we still have to set the DNS record or create the DNS record back into the Blucat environment, right? And so that's where we're automating against. That's cloud. That's back to cloud. That's not an SD-WAN, but the same conversation applies here. I need a tenant. The end goal for ever trying to consume this is I need a tenant. And so as long as we understand all of the elements of a tenant, right, and all of the different applications that are going to create that tenant, and the ones that are Blucat specific. The ones that are Blucat specific are the routes that are the subnets, right? The IP addresses that are going to be stood up on any given one of those subnets, and then the namespace, both the forward and the reverse, that goes with those computes or those IP addresses inside of those subnets.
Does the product have any ability to use SNMP to query the IP address table on the device?
So yes, and that's been there for quite some time, actually. That goes back to our discovery process where we can, if we're going to go in and discover any given network, we can do it a couple of different ways. We can use it in the very traditional and highly acclimated ping, right? Which is a bad idea, but we have the ability to do that. And then, yeah, we can go SNMP against the route tables and ARP cache. That's generally how our IP discovery works.
The SD-WAN tie-in to that is that you may want to allocate the private or the LAN subnet at the office, but you probably have ISP-provided addresses on the transport network or MPLS provided addresses, and putting those in manually at any kind of scale could be extremely painful.
So here's what's interesting about that, right? And I get this. I'm not sure my opinion here matters, but I'm not sure I agree with always having one mechanism or one place to do discovery of any given network from, right? I believe in spreading that load wherever, with whatever tools are available at the time in the place where you're trying to discover, because those tools know best what their ecosystem looks like, right? And how to go discover that type of information. And through our automation platform, we have the ability then to interact with those tools directly. We don't actually have to go do the heavy lifting of figuring out how to get over there and the credentials to get there and all the minutia that represents the challenges that we find in doing a centralized IP discovery of any network. So the automation platform has even more flexibility here to interact with those tools.
Fair enough. So you could react to the central controller or whatever for the SD-WAN if it can do.
Absolutely. Yeah. And so the good thing about, so traditionally, we would think of, listen, we are the listener and receiver of your requests, your very specific requests. Give me, an available IP address. We're not the trigger or the sender of that request. But now through the automation direction that we have taken, we can be, right? So if by some other mechanism, by the way, Noel just pointed out a very good point. I keep talking about our automation platform as a come to us platform, right? It certainly is that, where we set up RESTful endpoints and you can come and consume us. This is also where self-service web portals can be set up, or self-service portals can be set up if you don't have another portal to go to. So we can be both, right? So we can be a trigger point and a place to come consume data from us, both. We can act both at the same time, right? So if at some point some other trigger says, I need to know what the IP space looks like over there so that I can connect to it through SD-WAN, for example, it can be used for both a trigger point and a consumption point of our own data.
I think one of the surprising things for us a lot of times when we talk to customers is how often they'll tell us that they're still doing IP address and DNS allocation via email, or go ask the IT department or what have you. And by providing the IT constituents with a meaningful self-service workflow, that they can kind of just go through, get the record that they need, and get on with their business has been very valuable for a lot of big customers. And it always surprises me. I ended up in a room at one point with a large financial organization in Phoenix, and they told us that it takes them 2 weeks to deploy a host record. And I use their services. I have their card in my wallet, and I was absolutely shocked, because their public services are very, very good, but internally it was a very antiquated system for doing IP allocation.
Yeah, I think that's a good point, and we've got about 20 minutes left or so, and so. Sorry? Yeah. Why don't you set me up for that? Start off. Yep. Okay. Kick that conversation off.
Sure. So one of the things that we haven't really talked about yet today is what we're doing internally for DNS. We've talked a lot about the words visibility and control, and we haven't really talked about kind of how we are able to accomplish that. Traditionally, from a DNS perspective, and Jim said it earlier, our CTO described DNS as a chump. It asks for a query, it gets a response, you go where you need to go. If you get an NX domain, the NX domain is passed back to the client, it doesn't go anywhere, and that's the end of it. What we're able to do, we've changed the way that we architect DNS to where the first hop DNS server, so the DNS server that is aware of the client IP address, is able to track every single query from that device. And if you guys all think about, if I were able to look at the queries coming off of your endpoints, whether it's your laptop, your phone, what have you, over the course of a day or even a week, and you think about the amount of data that I would be aware of for you, that's kind of the visibility that we're talking about. I'm talking about knowing what SaaS applications you're consuming. I would know what time you come to work in the morning. I would know what time you stop working in the evening or don't stop, as a lot of us, I think, probably do. I would know probably what your favorite sports team is. And so what we're doing is inserting the first hop DNS server to be a server that in real time logs every query and query response, which is really key. When we talk to threat hunter partners that we have, what they tell us is the query is normally pretty innocuous, right? You're going to a site, you know where you're going, but the query response is really key, especially during a forensic analysis. And so we deploy as a first hop DNS server this endpoint that will kind of log every query and also allow you to apply policy. And the policy can be really one of two things. It can be policy based on either static or dynamic domain lists that you deploy. So maybe you have, as an example, and I love this example, Jim and I were joking about it last night, but our CTO talks about a large retailer that you guys probably all buy home improvement products from. They have point of sale machines. The point of sale machines actually need to go to 78 different records from a DNS perspective. And so what they've done is they created a whitelist for that so that those point of sale machines can only go to those 78 records. Now they still have an access control list on the router that's upstream or the access switch that's upstream that these devices connect to. So they're not actually able to get anywhere else. But if they're querying Google, that's bad. They should never be doing that. And if they are, they're infected somehow, and you should rip them out of the wall. And you can say that about a lot of IoT devices, because a lot of IoT devices are physical devices that people have physical access to. It's very difficult. Most hackers will tell you if you have physical access, you can own the device at some point. So we're able to deploy, again, a first hop DNS server where you can actually apply some intelligence and some policy. The other place where that comes into play, which is really critical, and you guys have talked about Office 365, is in a traditional, I'll say, DDI deployment, what you see is the endpoints will generally go through the corporate infrastructure to go out to the internet, which is fine if you're completely based in the United States and you need to get to the localized version of Office 365. But if you're over in Japan or China or wherever, and you want to get the localized version, why waste the bandwidth going across those expensive lease lines to go to Office 365 and get the Americanized version that then you have to shift when you could just create an exception and go straight out? So on those first hop DNS servers, we actually do intelligent namespace routing where we can say, if you want to go to this set of hosts, go directly out the local WAN link and just get resolved by a local resolver, local external resolver, instead of going through those expensive lease lines going out to the internet. So that's a use case. Another use case would be, and again, JD kind of talked about it when we were talking about cloud earlier. We were working with a large media company. They've got a cloud presence. They've got situations where they have some Route 53 DNS. They've got some of their shadow IT deployments are using a bind server that's deployed in a VPC. They've got some deployments where they're trying to get back to the on-prem data center-based DNS servers, and they don't have a way to do that because They'll get a phone call from someone who stood up something in a VPC and doesn't understand why they can't get back to the corporate DNS, but they don't actually have a path back there, or their local DNS server in their VPC is not aware of how to forward there. And so we're able to actually do that as well. So a lot of different capability baked into the first hop. Traditional DNS security was normally done with RPZs. Go ahead, Morgan.
Just before DNS security, how we can deploy, or can we deploy this solution inside service providers? Why I am asking this? When you talk about visibility and control, actually, you are logging a lot of things and lots of intelligence there. So if service provider you can deploy, and if they are doing LSN, so large scale net, CGNet, then how we will get this visibility and control?
I think the question becomes, in the service provider market, sure, absolutely. It's one of the questions you find, is there enough scale there? Is there enough speed there? Is there enough capacity there? Resiliency, redundancy, because all your clients want at that point is resolution, right? They want to get to the internet, for example. And so I think the question becomes, are you trying to protect the endpoint, or are you trying to protect yourself from the endpoint, right? In either case, you're getting visibility, because if you think about what we are capturing, they're going to query anyway. And so we might as well do some intelligent thinking or analysis around that query and do something about it if we need to do something about it.
So you can deploy it then in the ISP networks?
We can deploy wherever you want.
Then
right?
you need to deploy, I think, before LSN. I mean,
sorry?
before CGNet devices, right? Not after CGNet. So otherwise, you wouldn't have IP visibility.
We are a DNS endpoint, right? And so wherever you're going to put whatever apps you're using or devices you're using, if they are consuming DNS to get where they're going, you can put in our service point to do that, right? And so again, the idea here is, so once we've gotten that out of the way, is it possible to deploy there? Absolutely.
It's fair to say, though, it's not our focus, right? This is really meant to be an intra-enterprise solution.
Sure.
Right? And one of the key, so again, I was kind of getting to traditional DNS security sits at the last hop DNS server. So you're never aware of the client that's requesting to go to badsite.com, right? You have no awareness of that, because all you know is a downstream DNS server sent you that query. You're going to block it. The endpoint's not going to go out. You're probably going to even catch it on some of your other security devices, but you're never going to understand who that client was who did that. That's interesting. The other thing that's interesting is all of those prior DNS security solutions don't have any awareness of what's happening inside of the environment. So you have no way from a DNS perspective to monitor who's querying hosts in my data center and when and why, and what is my data center querying. And so we can essentially, by becoming that first hop, developing policies that monitor that type of traffic, we can do that. To his point, it's just a DNS server. We can deploy it anywhere you like. But really the focus is on helping you understand what the traffic is doing inside of your enterprise for IPv4 or v6, and really letting you know what your users and endpoints are doing, and putting a degree of control there that is based on policies that you apply.
Yeah, I think, so these are the ones that we were talking about before, right? When we talk about intelligent DNS, that's the service point that we're talking about. And what separates us against our competitors or people that are doing this in the space is we're doing the intelligent analysis above and beyond the intelligent routing that we're doing there as well. So they're both very important, right? So for you guys in the service provider space, intelligent routing, probably not something that you're going to consume. You would take a look at the analysis, you would apply policy, and moreover, remember there's two kinds of visibility. There's visibility in understanding what the networks are and what's on it, and then there's the visibility in understanding what our clients are doing on those networks by way of intention through DNS. And so with that, if you're simply, think about it this way, I know what you're about to do because of the question you just asked me. If I'm going to Gmail, I know you're going to check your mail. If I know you're going to YouTube, I know you're wasting time, but you're wasting my bandwidth too, right? No offense to YouTube. If you are doing whatever. But if you have a malicious intent, I know that through a couple of different mechanisms. I know it through threat feeds. I know it through categorizations of the emails or of the DNS queries that you're sending me. For example, tunneling or beaconing or things of that patterns that you might be doing in your DNS that have nothing to do with what you're asking me, but the pattern in which you're asking me, right? And so those are some of the analysis above and beyond. That might be something that the service provider market is interested in, but Noel is absolutely right. I mean, Bluecat is focused on the enterprise internal networking space and east-west and understanding and protecting, but it does apply in this matter. And I think to understand, can we get there? Absolutely. Is it the priority number one use case for us? No, it's not, right? But it's possible. Sorry.
Yeah, no, that's well said. So,
I think, with the little time that we have left, I think it's important to go back to this and look and understanding what enterprise DNS is and what we're doing with it. And so with cloud or security or visibility and control or automation, I mean, these are very vague topics. But here's the thing. Bluecat is very much focused on what our customers are trying to accomplish, not so much the DNS service itself, because the DNS service itself is now table stakes. The features and functionality around a UI, those are table stakes, right? It's how they are consuming us, the different environments that we can put ourselves into, the different use cases that we can solve against, and quite frankly, just the engagement model to go in and listen and find out, not make them use their own imagination for how they could use this, but in fact, how are our other customers around containers, for example, consuming this and using this to help them solve that problem. I had a customer meeting yesterday. I got to come out early and go up to San Francisco on Monday, rather, and talk about some of the issues that one of our potential customers is facing right now, and it is all over the board. They are looking at each and every one of these different problems, and they don't know where to start. They're using Microsoft DNS. They know that they're actually getting rid of AD. They're pushing that out to the cloud, and AD is what's providing them DNS, so they don't have a choice, right? And so with that, they're forced into this conversation, and they have all kinds of elements that they don't know what to do with, but they know rely on DNS. Everything relies on DNS. And so Bluecat is coming in. We understand the market. We understand the technologies. We have some brilliant pre-sales, post-sales, and care organization technicians and engineers that are all over this every single day. And we have the forefront, like teams like mine at Bluecat, that are going out and solutioning these, not just because we think they're cool, but we're getting those back from our customers, and we're solving the challenges and problems that our customers are facing. So that's our enterprise DNS. Are there questions, comments? Did we get it wrong? Did we get it right?
So this has sort of been a very high-level overview of everything that Bluecat does. What does this look like sort of for the boots on the ground, the IT teams that are managing DNS and DHCP from a life cycle point of view for, say, a DevOps team that are spinning up VMs and need records and maintaining those records and then getting rid of those records when they're done?
That's a great question. Look, I think, and I didn't use the whiteboard today. I'd intended to do so, but if now I would answer your question this way, I don't have time to do it, but I would do it on the whiteboard like this. What we find when we go in, and now it's every organization has all of these pieces. They already have DNS, they already have DHCP, and they're managing the IP space in one way, shape, or form, right? They have automation teams and DevOps, and they have some processes, whether they're automated processes or manual processes. And so what we do from the boots on the ground standpoint when we go in any engagement is we find out, what does their organization look like? What are your IT towers, right? Security, networking, AD, DevOps, automation, cloud, what are they, right? And what do each of those different towers own from a service standpoint? Most likely, they've got DNS in the AD. Sometimes they have DHCP in AD, but a lot of times DHCP belongs to the networking team, and they're using something for that. And then somebody somewhere is managing space through 14,000 tabs on some spreadsheet or 14,000 spreadsheets in general, right? And so what we do is, from a boots on the ground standpoint, we go get them all in a room. If you think about the way that an engagement used to happen, is we would go find somebody who would listen, right? And then impress them with some UI demo, get them all excited, and they go, yep, that's really cool. Can you solve these requirements? And can you do next available IP? And can we do this, right? And so, oh, and then can I see your API? Can you give me the API docs, right? And let me give it to our guy with a stapler and let him start banging it out on the keyboard, right? And so with that, that's not the way it's done any longer. We understand how to get these projects started, and as much information is to put them all in the room together. Whether they like to play together or not, they're going to have to if they're going to use enterprise DNS. They don't have a choice, right? And so we point out, look, you own this, and you own that, and you own this. And we go dig. We dig on their processes, and I mean dig in a good way. We go ask questions. What are your processes? What are your challenges? Where does stuff live? How do you go do automation today? And then we build the story with them around how it will look tomorrow, because it's drastically different than the disparate ways they're doing it right now. So we build the story, we draw it out, we typically put projects together, and then we have them understand that typically there is going to be an owner or a team that owns enterprise DNS. Today, there are 3 or 4 teams that own all the disparate services. There is going to be a team that owns enterprise DNS. And with that, they may not do the administration themselves, but they own the platform. And so if we need service points in this area for coverage, we deploy service points from this team for coverage there. If you need automation access, then there is an automation, typically there is an automation team that has access to the enterprise DNS system through this owner team. Go ahead.
And one of the ways we're able to get buy-in on that is the fact that we do make it easier for the other teams to consume it. A lot of times DNS is, you can't talk to the DNS team, you can't, or the networking team controls that. We don't have any say. And when you start to give those people the ability to have and again, we do it through role-based access control and giving them access to the data and being able to manipulate it in a way that's meaningful for their job. So from an operational perspective, we're actually able to talk to all of the teams, and we do that. I mean, we go into customers, and the first meeting is, maybe it's with a networking team, maybe it's with a guy who specializes in DNS, but we start to bring in the other teams in the company and really get them talking and figure out what are the workflows and things that we can provide. We talk about customer examples of some of the workflows that we've done for similar customers, or similar if they have other, we have a lot of customers today using ServiceNow, right? So we talk about how we integrate with ServiceNow and how we can provide them the ability to, through their ServiceNow ticketing system, they're deploying a server, let's assign the IP and the host name at that point, or what have you.
To answer your question more specifically, or I'll try to answer it more specifically like this. Through the use of our automation platform, it separates them from the keys to the kingdom. Right? This is the keys of the kingdom. And so we generally thought, everybody, do you have role-based access? Yeah, we have role-based access in the keys to the kingdom, right? But generally, the requests that they're making, they don't know anything about IPs, they don't know anything about names, about namespace or IP space. They just need a printer on the network as a very low level example, right? And so when the developers go out, they can then create the workflow here and never touch the actual keys to the kingdom itself, which is something that we don't want to expose. And so with that, if we give access here to create the workflows, and so you let your DevOps team do their testing against testing environments, for example, and certainly not against production, but they have the ability to then use their workflow sandbox out here, test against whatever configurations they're trying to alter to get the IP address and the name created, and then hand it back into the ServiceNow team, for example, to use Noel's example.
Yeah, and the other thing I'd say about it too is, so there's the self-service portal, which you can customize any way you want. You can put whatever back-end workflow against it you want. We have obviously a user interface that's web-based, but we've got multiple customers who don't do anything that isn't API-based. And I'm not, again, I have to put $5 in the jar if I mention names, but there's a social network down the street that does everything through code. They don't do anything through the UI. And our goal is to make sure that we're doing as much as we can to enable those customers to say, hey, here's how we want to consume this service. This is what makes sense to our business. We want to be able to move rapidly, and we can do that. You mentioned, and I think we were talking about it this morning, there's a storage company in North Carolina that does everything in OpenStack. And one of the challenges that they had with their prior solution is they're spinning up like 5,000 points of service for their OpenStack work in 5 minutes, and then 5 minutes later they're spinning it all back down. And they needed something that could keep up with that, and they were able to do that through APIs. And they can't do it through traditional Windows DNS or what have you.
Did that answer the question? I hope so.
Yeah, a little bit. I think, I mean, we probably don't have time for it, but what I was looking for a little bit more was an actual real-world example of even as low level as a printer. What does that look like for the team that wants to put it on the network and the IT team on the back end that would normally get involved to do that?
So the way we would draw that out, all right, so we do have 5 minutes. So the way we would draw that out, we'd ask them what their manual process, so low level to get that accomplished, right? Is that what you're asking? How do we turn it into a manual process?
Once you understand what they do today,
yep.
What does it then look like for them down the road?
Good question.
Once Bluecat has been deployed.
Now I understand the question a little bit better. So the things that we would do with this, where is your ticketing? What are your manual processes today? Or if you already have automated processes, what are they? Right? And what's your end state goal? Is it ServiceNow? Is it Remedy? Is it whatever? Right? Is it some homegrown system, which a lot of people are still using for ticketing? What is that system, and how do you automate against that system? Right? How customizable is that system? If it's ServiceNow, we all know how to do that, right? You create workflows there. We will go in and figure out what are the business rules they need around creating that entity. And so if this is a DHCP reservation for a printer, for example, we need to know several things. We need to know where you're trying to install that printer, right? And so that's the key number one, where are you gonna put it? And so we need to know the geographic or the network or whatever naming conventions you're using, whatever labels you're using to describe geographically where that is, and relate that to where the subnet is, okay? And so if you think about our data structure for just a second, the IPAM or the IP address information we have is sectioned like this. The IP space itself, blocks, subblocks, subnets, IP addresses, and at the same level as the subnet, we have the DHCP range, okay? And so with all of that, that's the very hardcore IP space hierarchy of our data set. What you will do then is relate the geographic or the business logic that you want to find that IP space, because your technician usually he's a printer guy or he's a whatever guy. He's not a routing guy or an IP guy, and he certainly doesn't know what VLAN he's about to plug into. Or maybe that's the way you get there, is to say, yep, hey, Noel, please go, hey, Jim, go install this printer over here, right? And so, okay, what information can you give me? It's on the 3rd floor in Dallas, on the 4th building or whatever, right? Or, hey, this is VLAN, whatever that might be, and however you're relating that data back. Then we build the workflow to say, yep, it's coming from ServiceNow. It looks like it's not we're not gonna say DHCP reservation. In ServiceNow, we'll say install printer, right? Build that workflow there with all the permissions and what's the word when not access, the approvals, thank you. The approvals that might need to happen within that ticket, send that request down to the workflow. And so we've built the business logic that you want around, great, how are we going to get to that data based off of the labeling, user-defined fields, tags, whatever it might be, that you've labeled that IP data with, and through the workflows, we'll go do the low-level calls to say, find the next available address in that particular subnet once we have found it. And if there is DHCP on there, all kinds of error corrections, if there is DHCP on that network, or even if there's not, rather, then go stick a reservation, and then that gets deployed out to the DHCP server that's handling that area. The logic in the workflow does not need to be aware of the DHCP server itself, right? That can be handled in data and the data relations that we have in our data sets, because the IP space, blocks, subblocks, subnets, DHCP range, and the IPs, we've related the service points to them for you already in the data set, right? So from an automation consumption standpoint, all you need to know is how to get to that subnet and the MAC address and any host name that you want to associate it with it, so we can add the DNS record as well. Once that's consumed, and we can do that through one exposed RESTful endpoint, whereby you say, give me DHCP, give me a printer. We have a give you a printer workflow, give me the data we want, we go to the hardcore API calls, we give you back a yes, no. For if it's a reservation, you've given us your MAC address, that's all you need to give us, right? We give you back an approval or a yes, no, it goes back in the ticket has been provisioned and deployed, plug in and go. Did that answer it better?
Yep, and then life cycle after that, so that printer is now gone.
So
Another workflow that says delete printer.
Absolutely.
So now here's the question. That's where I think DNS and DHCP fall down, is people retire endpoints, and that never happens. We threw this printer out, nobody tells the people in charge.
Yep.
And now you've got a reservation or an A record that live there forever in perpetuity. And somebody once every 12 months goes, oh, we need to turn on scavenging, and everything blows up.
So that's a great point. So I love the fact that you just said scavenging, right? Because that is a disparate word.
Right.
The word scavenging implies that you have a disparate management for your DNS information versus your IP information, and you can't tell between the two of them which one is in use or which one's been queried for. Through the intelligent routing, we can tell you, has that address been queried for? There's one mechanism. And this is another mechanism for going and spot checking a particular VLAN for the usage or in the ARP cache of a particular IP address, right? Because if they pulled the plug or whatever, that won't be there any longer.
So one thing about scavenging, I mean, we talk to customers of all sizes, and typically the questions we get the most about scavenging are the customers that are managing either some sort of point solution for DNS and DHCP, or they're managing IPAM through spreadsheets or something of that nature. We never get that question from someone who is already using some DDI platform. And the reason for that is because they've taken the time generally and it's not always perfect, right? But to develop the workflows for when they do, that now they have a way to pull that out of all of that easily, and they can provide that to their customers. And so that's one of the things that we work with our customers to do is kind of help them understand some of the capability that they have that they didn't before. Scavenging is definitely a problem if you're managing a Windows DNS environment and a Windows DHCP environment. But if you're managing a full EDI solution where you can give that person the easy way to just go to this website, take the server out of service, or have some automatic service that's polling and whatnot and can actually remove that, that's easy. Plus we can give you the visibility that, oh, you know what, that host hasn't been pulled in this period of time, so maybe you should decommission it.
Yeah, and it goes back, so now that we've opened the door to automation and the more flexible way to do automation in general, some spot checking against the usage of information that's already there can be done through the automated platform as well.